Hi everyone. So I've been working on a little project that I wanted to share with you. I've been buying these little DC motors from China, and they're really cheap. They sell for about $3.50, and this one in particular have a 200 RPM output shaft and a 1,500 RPM. If I'm not wrong, no, not 1,500, 1,500 RPM main motor shaft. So from there you can calculate your gear ratio and all the rest of it. What I wanted to do with these motors is include an encoder on it and control it using some kind of control algorithm, which I will design in the future. But I just wanted to see how this could be implemented, and I'll just show you what I've got so far. So this is what I've come up with. It's pretty simple. As you can see, this is a 3D printed case, which is used to mount this optical encoder, and this is the encoder disc with I can't recall how many steps it has, but I'll check that in a sec. And yeah, the motor fits right in there, and I made a connector for the terminals. So two connectors go straight to the motor terminal, positive and negative. Two go to the power of the optical encoder, and two are the outputs for, and of course, the optical encoder, terminal A and B. You would think this should work particularly well if it wasn't for this little guy here, which I thought I mounted the correct way, but apparently I didn't. So I'll just take this apart and show you guys what I'm talking about. So I've taken those two screws off, and as you can see, I can't take the motor out because the cables are soldered inside, and I don't want to cut these cables right now. So I'll just show you quickly as it is. Usually I'll just give you a quick explanation on how this works in case you don't. So basically this is a rotary optical encoder. It's got the disc as we saw, and it has little slots in it, and excuse me for my horrible drawing here, but it'll give you an idea. So if you only want to determine the speed at which the motor is spinning, you actually only need one sensor. You need, let's say, a sensor here, and that's all you would need. This sensor in particular has two outputs, so I know it has to have two sensors. And what I thought is, in order to, the other sensors used to measure the direction of rotation. So usually you have your other sensor next to the previous one, and based on how it turns and the pulses, I won't give you a detailed explanation here, but you can determine an output, and usually the pulse coming out of one terminal is a square wave like this, and the pulse coming out of the other one is a square wave as well, which is overlapped with the other one by half of the width. So the way I mounted this, I connected it to my DSO, and I was just getting one single wave. The second channel, channel B, was not outputting anything. And at the beginning I thought my sensor was broken or something was wrong. But then I went online and I found a website, I'll link it down in the description, where yeah, there was a pretty good explanation on why this didn't work. And the main reason is that for this particular sensor, looking at it in this direction, and you can actually see it right there, but I didn't notice that. Looking at this direction, the sensors are lined up top and bottom like this, which means that if you put these on the disc and this is your slot, you'll never be able to see what direction it's going, basically. And the only way of fixing this is to actually mount the sensor sideways. And this kind of works, but you get really close to this. I don't know if you guys can see this, but if you mount this on an angle, this disc gets really close to the base of the sensor, and it hits it. So it's actually not really good implementation. I think whoever designed this did it wrong. I don't think they realized they put the sensors the wrong way around. Anyway, figured that out, and by just playing with it, I noticed that actually the sensor actually works fine. It's just mounted the wrong way. So what I need to do at this stage is get rid of all this gunk, because inside here there's all the circuitry that holds and runs this sensor. I need to take all this gunk out. I think it's like just hot glue gun. And yeah, once I've got it out, I need to either design a new casing for it and 3D print it, or maybe I'll just be able to modify this one and mount it back. Definitely have to design a new one of these, I guess. So yeah, this is what I've got so far. I just wanted to share this with you, and I'll post another video when I get this done. And yeah, so once we have this sorted out, it would be pretty interesting to see how accurately we can control this. And I've just checked the actual lines on this disc are 100, which means we can count 100 pulses per revolution, which is actually not that great. Gives us 3.6 degree resolution. 3.6, sorry, degree resolution, which is not great, but it's a good starting point. Eventually, I wouldn't mind mounting this on the actual shaft of the main shaft of the motor, but it's a bit complex, and we might have a look at that in the future. Anyway, thanks for watching, and I'll keep you updated when the next video comes up.